Well, good evening everyone. Today I prepared this video to explain the concept of basic proportionality theorem or Thales theorem. As far as this theorem is concerned, it was introduced by a famous Greek mathematician whose name was Thales. Okay, now let's see what this concept says. What do we have here? If a line is drawn parallel to one side of a triangle, now it means that we draw the triangle, understand the concept of this theorem. We are given a particular triangle. Now I am going to name the triangle. The vertex of triangle be A, B and C. Now what do we have in the statement? If a line is drawn to one side of a triangle to intersect the other two sides. Now these are the other two sides. As you can see, I have taken side AB and AC as the other two sides. And suppose that line passes through these 2 points. Let me name this point D and let me name this point E. Alright. So we can say that the other two sides are divided in same ratio. It means that if this line is in parallel to the other line, that is any one of the sides of the triangle, then this line divides the two sides, this one, the side AB as well as AC, in two equal ratios. This is what we are supposed to prove. Alright, so very first thing that we are going to do is, first we will join BE. Join BE and draw an altitude from point E on AD. So that's the altitude. Now I am going to name this altitude N. Now let's make the sum easier to understand. First, we'll erase this section from here. Let's erase this point from here. Now do you see two triangles here? Which two triangles can we see here? We can see triangle ADE and the second triangle BDE. Okay, so we'll take in triangle ADE and triangle BDE. Now we know that the formula for, if we compare the area of these two triangles, we see that we have the altitude. Right? So when we are given the altitude, then obviously the area of triangle is given by the formula half into base into altitude. So comparing the areas of these two triangles, which triangle? Let's see. Triangle area of, let's write it like this, area of triangle BDE upon area of triangle ADE is equal to, well, you can do one thing, you can take this triangle on top, ADE the smaller one and BDE on top. Now we'll use the formula half into base into altitude. Look at this triangle ADE. In that, what is the base? Half into base. If you see, the altitude lies on AD, so the base is AD into altitude. This line which falls on AD, that is termed as the altitude EN. Now let's see this triangle B, D and E. Now for this triangle, the altitude is outside the triangle. The altitude is EN. So replacing the values, you get here the basis. What is the base? The base is BD or DB. And the altitude is the same, EN. Now cancelling the values, half, EN and EN, we are left with AD upon DB. So this is our first equation or the value that we generate from these two triangles. Alright, now if we take the other side of the triangle, when we take the other side of the triangles, what have we found? Let's do it further. Now I'm gonna increase, I'm just gonna increase this line from here. Okay, now instead of joining BE, I'm gonna join C and D. Okay, I'll remove this altitude from here and draw an altitude from D and name it M on the base AE. So you can see now the triangles have changed. Utilizing the same method for solving for this triangle. Okay, we'll get on the equation. So let's write it down. In triangle. So if you see, now we will take the triangles ADE once again, and the other triangle is DEC, and use the same formula here. Right? So let's write in triangle ADE and triangle DEC. Using the formula, so what do we get? Half into. Now let's see. In the triangle on top, we see that the value of the base, the altitude falls on side AE. So the value of the base is AE and altitude is DM. Similarly, for this triangle, let's write it. Area of triangle ADE upon area of triangle DEC. So replacing the value half into, if you see, for DEC, the altitude falls on this extended side CE. Okay, so you will take the value as EC, that is the base, into altitude is the same. Cancelling the altitudes and half, you are left with the value AE upon EC. So this is my second value that I have got after evaluating. Okay, two different triangles utilizing the formula of area and area. Now what else do I see here? I see that triangle BDE. Okay, so let's complete this figure once again. Let's draw the complete figure. Now what do I see? The third thing that I see here is, let me join this. Now what else do you see? Okay, we have already proved that this triangle, the area of this triangle and this triangle is in proportion, that triangle, this triangle is in proportion. Let's see two different triangles here. Which two triangles can you see? Triangle, or taking triangle, the triangle which I am going to take is BDE. And look at the other one. See, the triangle which lies on the same base. One is B, D and E. Okay, and next is DEC. So, what can we say about these two triangles? They are on the same base. Both of these lie on the same base and between the same parallels, as you can see. Okay, so you can write it here, lie on the same base. Okay, and also there are two parallels here and lie on the same base and between parallels, between the same parallels. So which are the two parallels? So we can say that BC is parallel to DE. Okay, so what else can we say? We can say that even these two triangles, the areas of these two triangles is equal. So we can lastly write that area of triangle BDE is equal to area of triangle, or you can write AR in bracket, area of triangle, the other one is DEC, they are equal. So this is my third value that I have got. So finally in the last line I will write from 1, 2 and 3. From 1, 2 and 3. So I can write here from 1, 2 and 3 that the values I have obtained. I can say that these two values, that is the value which I get in first one, AD upon DB is equal to AE upon EC. Okay, and if you want to see, this is the end of the Thales theorem or basic proportionality theorem. And if you want the ratio of the other values, you can add +1 + 1 here and get the other values. Thank you.